We're now looking at part B of the Junior Challenge, question 2, RU Paths. So there's our A path and our B path. Now, this is a very typical type of question. We found one path already that had 8 turns, and we're wondering, could we find more? Could we find more than 8 turns? More interestingly, here's the harder question. Once we think we've found out what the maximum is, can we explain why it's the maximum? This is actually the hardest part when you're doing something like the Junior Challenge. We often can find a maximum and we can convince ourselves, but can we provide a good mathematical argument why? I'm pretty confident I can get more than 8 turns. But, before I do that, I'm going to be a little bit methodical. I'm going to restrain myself and see if I can find the smallest. What's the smallest? Could I do it with 0 turns? No. I think I have to do it with at least 1 turn. Could I do 2 turns? Well, let me try that. What if I went here, here? Oh, that's 3 turns. 1, 2, 3. So I can definitely find a 3-turn path. I wonder, can I find a 2-turn path? How about, well, I've done a 3, I've done a 1. 0 is not possible. I've done a 3. Can I do a 4 or a 5 or a 6 or a 7? I know there's an 8. And hopefully by the time I've explored these different paths, I can see that there is perhaps more than 8, and I could explain why. I think it's also worth asking the question, what does it take to get from A to B? What do you have to do? The notation talked about using R's and U's. I'm actually tempted to write what this path is. So what's this path here? This is an up, 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 right, 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 right. Okay, so this path is U, 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 U. There are 5 of them. And 1, 2, 3, 4, 5, 6, 7. And in fact, I'm just going to mark with a different color my transition point. There's the turn. There's the 1 turn. What about this 3 path? Let's try and write the 3 path. The 3 path was a right, up, 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 up. Well, there's another up, right, 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 right. And so if I write that path all at once, it's an R, U, 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 R, 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 R. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We've got to get this right. And a U. Oh, that's interesting. There's my 3-turn path. Let's just mark the turns in there. So there was a turn there, a turn there, and a turn there. So it looks like the turns happen when we switch from an R to a U or from a U to an R. I also notice that all the paths seem to have the same number of U's and R's. And that makes sense, doesn't it? Because if you think about it, we've got to move a certain amount right and a certain amount up. So it's at this stage now that the Junior Challenge reveals why it is a challenge. We're not going to get an instant answer here. It's going to take time. And I'm going to tell you that when I first played with this problem earlier this morning, I think I spent a good 20 minutes or so exploring this. Yeah, good 20 minutes or more. You might spend some more time and get some more insights. That's okay. This is not a problem that can be solved instantly. It's going to take time to get insight. And remember, for our answer, we need to explain why is it a maximum. Once you've found a maximum, we need to explain why it's a maximum.